In addition to the Pythagorean theorem, triangles have several more unique characteristics that are useful in everyday math. For instance, the three angles of the triangle will always add to be 180 degrees. So, if two of the angles are known, it's easy to calculate the third angle. Another unique characteristic is that the area of a triangle can be calculated by multiplying 1/2 times the base times the height. The base of the triangle can be any one of the three sides, usually drawn at the bottom. The height of the triangle is the length perpendicular to the base. If the base and height are known, the area can be calculated. Finally, for all triangles, if two sides are equal, the angles opposite those sides are also equal. Similarly, if all three sides are equal, all three angles are equal. In addition to the characteristics that all triangles share, right triangles have several characteristics that are quite unique. Before we cover the details of those characteristics, it helps to identify the various parts of a right triangle. A right triangle is any triangle that has one angle equal to 90 degrees, which is called the right angle. The hypotenuse is always the side across from the right angle. When discussing either of the remaining two angles in the triangle, you'll often hear the terms opposite and adjacent applied to the sides of the triangle. The term adjacent identifies the side next to the angle that's not the hypotenuse. The term opposite identifies the side across or opposite from the angle. The terms opposite and adjacent can apply to different sides of the triangle depending upon the angle in question. Sine, cosine, and tangent are the three main functions in trigonometry and are often shortened to sine, cosine, and tan. These functions relate the ratio of the sides of a triangle to its angles. For instance, the sine of an angle is equal to the ratio of its opposite side and hypotenuse. Cosine is equal to the ratio of the adjacent side and hypotenuse, and tangent is equal to the opposite side and the adjacent side. Since the sine, cosine, and tangent functions are ratios, the actual length of the sides can vary and produce similar angles. For instance, in this triangle, the sine of angle A is equal to 3/5. If we doubled or even tripled the size of the triangle, the ratio would still simplify down to 3/5. Since the value of the ratio is the same for a given angle regardless of the size of the triangle, these functions are easily determined with a calculator. If any one variable in the equation is unknown, we can use the sine, cosine, and tangent equations to solve for the missing value. For example, if we know that angle A is 35 and the opposite side is 7, we can solve for the hypotenuse using the sine equation. First, rearrange the equation to solve for the hypotenuse. Then, using a calculator, enter 35 degrees into the sine function. Substitute the value into the equation and calculate the results. Similarly, we could solve for the adjacent side using the tangent equation. Since not all triangles are right triangles, it's useful to know how the trigonometric functions sine, cosine, and tangent relate to regular triangles. The law of sines states that the side of a triangle divided by its opposite angle is equal to any other side divided by its opposite angle. So, for any given triangle, side A divided by the sine of angle A is equal to side B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Once again, if several of the values are known, we can rearrange the equations to determine the remaining values that are unknown. For example, if angle A, side B, and angle B are known, what is side A? Rearranging the equations and substituting the values will allow us to solve for side A.